Bees are a part of the Hymenoptera order known of their membranous wings, which is the third largest order of insects comprised of sawflies, wasps, bees, and ants. There are nearly 25,000 known species of bees, divided into 4,000 genera and 9 families. They range in size from tiny stingless bee species that are less than 2 millimeters long, the largest species of leafcutter bee, whose females can attain a length of 39 millimeters. Bees are adapted for feeding on nectar and pollen.
A bee's body is covered in lots of fuzzy, branched hair that collects pollen and helps regulate body temperature. The body also has 3 sections: the head, the thorax, and the abdomen. Pollination is the transfer of pollen from the male part of the flower, the anther, to the stigma, the female part of the flower. Some plants pollinate themselves or with wind dispersal, while other plants rely on other organisms for the pollination process. Pollination is essential for plant reproduction. Pollinators are a critical component of natural ecosystems because the majority of the world's plant species rely on animal pollinators for sexual reproduction. Wild species such as honeybees are said by researchers to be responsible for pollinating around 1/3 of the world's crop production. The Food and Agriculture Organization of the United Nations estimates of the 100 crop species that provide 90% of food worldwide, 71 are pollinated by bees. Bees are essential to biodiversity and to plant reproduction. As well as the important role that bees serve in our economy for food sources, bees also beautify the planet. By keeping flowers pollinated, bees perpetuate floral growth and provide attractive habitats for other animals such as insects and birds. Pollinators perform a critical function in ecosystems, and their decline could affect plant communities and the pollination of crops. This suggests that population growth of many wild plant species could decrease with increasing human land use and subsequent pollinator decline. Demand for insect pollination of crops has tripled, and the importance of wild pollinators has become increasingly apparent. There is said to be a pollination crisis in which crop yields begin to fall. Species richness of wild bees and other pollinators has declined over the past 50 years, and some species are undergoing major declines and a few are considered endangered. In North America, some formerly abundant and widespread species such as Bombus terricola and B. occidentalis underwent severe declines from the late 1990s onward and now occupy only a small fraction of their former range. 75% of our crop species benefit from insect pollinators. The demand for insect pollinators in farming has tripled during the same period. A few examples of the foods that would no longer be available to us if bees ceased pollinating our agricultural goods are broccoli, asparagus, cantaloupes, cucumbers, pumpkins, blueberries, watermelons, almonds, apples, cranberries, and cherries.
Colony collapse disorder is the phenomenon that occurs when the majority of worker bees in a colony disappear and leave a queen behind with a few nurse bees to care for the queen. Beekeepers began to notice unusually high losses in 30 to 90% of their hives in 2006. CCD may also be contributing to the global decline.
There are multiple factors contributing to the decrease in bee populations, one of which is habitat loss, which has reduced the abundance and diversity of floral resources and nesting opportunities. This has been done by the conversion of natural or semi-natural flower-rich habitat to farmland. The urbanization or building of roads and other infrastructure also contributes to the fragmentation and degradation of habitats. Wild and managed bees are also exposed to a succession of emerging parasites and pathogens. Pesticides are the most controversial and debated cause of bee declines. The intensification of agriculture and increasing reliance on pesticides has led to chronic exposure to agrochemicals. Stressors do not act in isolation and differ from place to place. For example, both pesticide exposure and food stress can impair immune responses, making bees more susceptible to parasites.
Neonicotinoids are a relatively new type of insecticide with a chemical relation to nicotine. They are meant to act on receptors in synapses, which eliminates target pests, but ultimately causes neurotoxicity in bees and other beneficial, non-target invertebrates. They are convenient in agriculture because they are applied to the seeds or the soil of crops and are taken up by the plant, compared to having to spray the crop. The chemicals eventually contaminate the plant's pollen and nectar that the bees feed on. One study fed bumblebees the same amount of a widely used neonicotinoid called imidacloprid as a rape plant would have received, and saw that the exposed colonies shrank 10% compared to those unexposed, and that the exposed colonies almost completely lost the ability to produce queen bees, which are the only bees to survive the winter to start new colonies. This implies a population-level impact. A French study tested the effect of a new generation neonicotinoid called thiamethoxam on honeybees. The bees were tagged and their activity was monitored. The bees exposed, supposedly to commonly encountered levels of thiamethoxam, had a high mortality rate and nearly a third failed to return to the hive. Regulations on pesticides often only focus on their use on intended crops, but a 2015 study looked at wildflowers near the agricultural area that also took up the neonicotinoids. They found that wildflowers had a higher but more variable concentration of thiamethoxam and were also found outside the blooming periods of flowering crops. In the June through August study, by the last month, 100% of the pollen intake was from the wildflowers. Bees that are not killed outright by pesticide exposure can experience developmental defects, weakness, and damage to the immune system. The effects of pesticides on bees are additive, meaning that since bees forage in many areas on many different plants, they would be exposed cumulatively to all the neonicotinoids in the pollen and nectar they were exposed to. The neurotoxic effects of pesticides have been shown to damage bees' learning, memory, and navigation. For insects that forage, memory is of the utmost importance. They learn features of plants that indicate pleasantness or unpleasantness, and thus whether or not to return to specific plants. They also memorize the location of their hive based on surrounding landmarks. This damage and resulting homing failure is proposed to be one of the largest contributors to colony collapse disorder. In 2013, the European Union voted in a temporary 2-year restriction on neonicotinoid insecticides. The ban restricts the use of imidacloprid, clethianidin, and thiamethoxam on crops that attract bees. Not included are crops non-attractive to bees, winter cereals, or in greenhouses, as well as a ban on their sale to amateur growers. The sale of seeds already treated with any of the neonicotinoids is prohibited, with the exception of research purposes. Many retailers have already removed neonicotinoid pesticides from their shelves. After the temporary ban is lifted, people worry that a permanent ban on neonicotinoids will lead farmers to revert to older, more harmful pesticides. Many alternatives have been suggested, such as natural pest predators, crop rotation, and alternative chemicals that of course passed the test the neonicotinoids failed. Early this year, the European Food Safety Authority launched the Must Be project, which aims to holistically assess the multiple risks and stressors on honeybees. Activities already underway include statistical analyses of the dataset on bee mortality, a scientific opinion on the definition of a healthy bee colony, and reports on the toxicity of multiple chemicals to bees and their effect on bee population dynamics.
Urban beekeeping improves pollination for plants in cities, which in turn helps improve overall biodiversity and resilience. It also provides educational and recreational opportunities. City Council passed an amendment to the Animal Licensing and Control Bylaw on April 28, 2015 to permit beekeeping in the cities. There are various steps to become an urban beekeeper, the first being to review the city's beekeeping guidelines. The second step is to register with Alberta's Premises Identification Program. This requirement is part of a traceability system designed to address potential threats of disease outbreaks that could affect animal health, public health, and food and safety. Thirdly, register with a provincial apiculturist. And last but not least, apply for a beekeeping license. Be prepared to provide information about your beekeeping site, your training, your mentor if you are a first-time beekeeper. Studies show that honeybees are healthier and produce more honey in urban settings where there are fewer pesticides sprayed and a greater diversity of flowers. This could address growing food demands as world population increases.